Hello, pre-calculus students. We are ready to finish lesson 8.4. So you will notice I am on the back side of lesson 8.4, and our job is to graph these conic sections today using our graphing calculators. Now, the key when using the graphing calculators is, of course, you know the goal to using a graphing calculator is you have to have your equation in the form y equals. And I don't know if you guys are reading up there, but notice it does say in order to do this, we must be able to complete the square. We won't always have to complete the square, but it is an option on several of these. So let's start with A. My general rule of thumb here I'm going to say is, okay, we're solving for y, so we need to start by getting the y's by themselves. And I do always try and take a moment to look and see what type of y terms I have. Since I have a y squared and a y term, my thought would be to get those y's by themselves. Now, if you've paid attention to what we've done lately, when we have a y squared and a y term, that's going to set us up for a certain process. So, if I keep my 16y squared here on the left, plus my 64y on the left, and then all other terms have to move to the right. Now, you are going to notice me leaving a gap. I'm going to subtract over the 9x squared, so it's going to be negative 9x squared. There's a minus 18x, so I'm going to add over 18x. And there's a minus 71, so I'm going to add 71 to the other side. Again, common step when there is y squared and y term is our process is going to be to complete the square. So, and I don't know that I really have another option for this one other than completing the square. I guess I could come up with another option for you, but I think completing the square is going to be the best. So, if you would, when completing the square, first of all, remember what form do we have to have this in? And the form we're going to have this in is a 1y squared plus by, which means we need to take this 16 and factor it out. So I'm going to take 16, factor it out for my y terms. When I factor the 16 out, I'm left with y squared plus 64 divided by 16 is 4y. I'm going to leave my gap in my parenthesis. On the right, I'm going to keep my material the same. It's going to still be negative 9x squared plus 18x plus 71. Okay, do you remember? How do we complete the square? It is b divided by 2 quantity squared. And what is my b term here? B is the new 4 right here that we're going to use. So 4 divided by 2 is 2, and 2 squared is 4. I'm going to take that 4 and I'm going to add that 4 there in the gap on the left. If I add 4 on the left, remember we need to add 4 on the right. But you guys are hopefully correcting me here. It's not just a 4. Because that is in parentheses multiplied by 16, it's a 4 times 16, which is really 64. The step always after completing the square is to factor. Carry the 16 down. And then this factors into two identical sets of parentheses. Square root of y squared is y. Square root of this last 4 is 2. And the middle sign is a plus, so we're going to use plus. So we have 16 times y plus 2 quantity squared. My right side, I'm just going to clean up. Negative 9x squared plus 18x plus, and then I would go ahead and add 71 and 64 which should be 135. Okay, from here, after you've completed the square, your job is to solve for y. And so as you look at that y and start thinking about how to solve, my recommendation first would be to get rid of the 16. How do we get rid of the 16? We're going to divide. Since it's 16 times y plus 2 squared, we're going to divide. So if we divide the left by 16, it's y plus 2 quantity squared. If we divide the right by 16, well, it's not looking very pretty, so I'm just going to make it a big old fraction. Negative 9x squared plus 18x plus 135, all divided by 16. If it's y plus 2 quantity squared, you all know the step is to take the square root. If I square root the left, we square root the right. The square root of y plus 2 quantity squared is y plus 2. What happens when I take the square root on the right? The square root of that big fraction is the square root of that big fraction. Now, keep in mind, because we're in an equation format, don't forget the plus or minus the square root of negative 9x squared plus 18x plus 135 all over 16. And that is all still under the radical there. Final step, if it's y plus 2, to get the y by itself, we're going to subtract 2. If you subtract 2 on the left, subtract 2 on the right. So now, to write a final answer, a couple of things. First of all, I like to put the negative 2 first. So I'm going to say y equals negative 2 plus or minus. And one little cleanup I see I can do that would be a little bit nice. You don't have to, but in this square root, if you look at the denominator, notice the denominator is 16. So a common step here to take would be to just leave the numerator under the denominator. So square root of negative 9x squared plus 18x plus 35, and then put that whole radical over 4. Because this is something we are entering into the calculator, there are several different ways you could leave this. This right here would probably be one of the best ways to leave it. We have y equals negative 2 plus or minus the radical over 4. If you left this all one big radical here and just said negative 2 plus or minus, and it was still 16 and under the radical, that would work as well. There is, I just realized I forgot to write a 1 here for 135. Probably unbeknownst to you, 9, 18, and 135 could actually all divide by a 9. And if you divide them all by 9, the square root of 9 is 3, and so that's actually a perfect square you could pull out. It's not something you have to do, but you could. Let me write that out so you can see it as an option. Y equals negative 2 plus or minus. So if you factor out a 9 under the radical, square root of 9 is 3. 3 would go out front of the radical. Divide everybody else by 9, leaving you with negative x squared plus 2x plus 15. And then it would still all be over 4. Now, if you plug that into your calculator, that's going to give you the same answers as what you have down below. Okay, let's see how this works here. This little black box in the bottom corner is the camera. So I discovered new experiments here that I can have the camera on. So we are going to try where, hold on here, I have the camera open, and I'm going to show you what this looks like on the calculator. So if you want to pause and try yours on the calculator, you can. I just kind of have to hold it above here. Now, I went ahead and I already have them typed in. You'll notice as I have them typed in, I have -2. First of all, plus or minus, forgot to mention, that means two equations, right? So I have y1 as -2 plus the fraction, y2 is -2 minus the fraction. The other piece I'll point out is, notice, because I took the square root of 4, it's not under the radical. Now, if you have a calculator that does not do the fraction, you might have to use parentheses within your radical. Now, let's see. If I go ahead, I know I'm already on Zoom 6. Pretty sure I am at least. If I go ahead and hit graph, I get what is supposed to be an ellipse. So if you've graphed yours, typed it in correctly, your ellipse should look similar to my ellipse. Now, notice, yes, for whatever reason, the ends don't connect up exactly right, and they're kind of lopsided, which always makes me question it. But yeah, this is the correct picture. You can pause it here if you want to see that picture. I'm going to put my iPad back down and sketch the graph, because how do you show me that you got this done? Well, you put all the work and what the equation is in terms of y equals, and then you graph it. So sketch me a graph. So I would pay attention to where some of the intercepts are, so you know. Okay? So let's see what we can do with a graph. And I'm not sure how great my sketch on here is going to be, but I'm going to try. So let me get myself a set of x and y axis here, actually. And I counted out, I think, 5 right. I counted out 1 up. I counted 3 left. And I'm going to count 5 down if I can. Some of the points that I can put on there, I saw that intersected the y-axis at approximately 1 and approximately -5. I saw it intersected the x-axis at approximately -2 and approximately 4. If I try and guesstimate where the vertices are, the ends, the left end is a little hard because it's not the best, but I'd say over somewhere around -3 and then maybe down 2 or 3, somewhere in there. If I look at the right one, it's a little bit easier to tell maybe. So that is over 5 and down in that 2-3 range. So there I have some points. This is going to be one of those ellipses that doesn't look the best, but that's all right. I tried. My ellipse is definitely a little lopsided, but we'll take it. Looks something like that. So your work, the y equals equation, and your graph is what would give you a complete equation here. Okay, pause the video if you need to get anything else done. I'm going to go ahead and move on to example B. Now, again, first thing I'm doing is I'm checking to see, okay, what is it I even have here? And you'll notice, looking at this one, the only y I have is an xy term. I don't have a y and a y squared. That makes life a little trickier, and I might need to complete the square. I just have a xy term that can become a y term. So use your basic equation solving skills and solve for y. So if it's 2xy minus 9 equals 0, I'm going to add 9. If I add 9 on the left, I add 9 on the right. And I have 2xy equals 9. To get that y by itself, I'm going to have to divide by 2x. If I divide the left by 2x, I divide the right by 2x. Two x's cancel. Y equals 9 divided by 2x. And I'm going to leave it just as is, as y equals 9 over 2x. If I go ahead and graph that, again, I prefer to use a fraction bar so I don't have to worry about any parentheses. If you don't use a fraction bar and you use division, you need to do, I believe, 9 divided by parentheses 2x to get it correct. And I'm going off of what I think will happen there, but I think that's what we have. Okay, so I just realized, oh well, I'm learning on this whole using the camera at the same time here. And I forgot I could make the camera bigger while I am graphing. And I didn't do that. But, okay, so if I hold this up again, let me get my calculator. Forget where it is. There we go. So if I hold this up like this, I believe I can... Nope, it's not letting me. I believe there's a way I can pull. Sorry. It's not letting me. There we go. Pull and make the calculator a little bit bigger for you. Should have done that in the last one. Sorry. So here, I have it typed 2 different ways. I have 9 divided by 2x as a fraction, or if you use the division sign, 9 over 2x. If I hit graph, you will notice it looks like such. And that is definitely a hyperbola. This goes back, if you recall, to the types of hyperbolas that we talked about back in lesson 1.3. So a basic sketch here showing the hyperbola in the quadrant 1 and quadrant 3 would take care of the problem. In other words, I'm not going to take time to put any points or markings on it. I'm just going to draw the hyperbola. So, I'm going to go back to drawing here. And I'm going to draw my hyperbola in quadrant 1 and in quadrant 3. Looks like that. That would make me happy. That would give me the idea that you tried it and you got it all there. Now, I have to work. I'm supposed to be able to drag the corner of the calculator down and make it smaller. And I don't know if I can move it or not. So I guess I'll just make it real tiny for the moment and go from there. Because we have one more problem to do, and that is C. So let's start looking at C here. And C, start by checking out what type of C terms do you have. And as we look at C terms there, not C, my apologies, Y values. What type of Y terms do we have? As we look at Y, you will notice there is an XY term, there's a Y squared term, and there's a regular Y term. So that's kind of a game changer. That changes how we have to work this problem. Okay? Because of the XY term, I don't believe you can really do a complete the square type option. So we're going to do something a little different. And what I'm going to ask you to do is to try and get this equation in the form that we could use a quadratic formula. Now, we're trying to solve for y, which means I'm going to ask you to put this in the form of ay squared plus by plus c equals 0. Meaning I want all y squared terms, then I want all y terms, and then I want all non-y terms, so just any leftovers. So if we rearrange that order a little bit, in terms of y squared, I just have one term, and that is 4y squared. Okay? plus. In terms of y terms, so anything that has a y to the first, I have a 4xy and a minus 90y. So I'm grouping those together. And then, lastly, all of your other terms. Anything that does not involve any type of y. So that means I have an x squared minus 30x and plus 450. And my equation still equals 0. So, notice I have a y squared term here. I have my y terms. And then I have my non-y terms. And so what I've done is I've just broken this up so I can put it in the form of ay squared plus by plus c. Now, do you catch where I'm going with this? I mentioned it earlier. If that's the case, we can then use quadratic formula. So instead of saying x equals, since I'm trying to solve, I'm going to say y equals. And it's going to be, remember your quadratic formula? Sing it if you need to. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So there's your quadratic formula you're using. In order to use quadratic formula, remember that we have to be able to identify our a, b, and c values. So in terms of 4y squared, I think you can already identify that a is the coefficient of the squared term, so my a value is going to be 4. In terms of b, I need to know what my coefficient of y is going to be. So basically what I'm going to ask you to do with this next two terms is to factor out a y. So if I factor out a y, and I'm going to put the y at the end, if I factor out a y, I'm going to have 4x minus 90 times y. My point of doing that is I now have what is my coefficient of y, what goes with y. And that is the whole expression of 4x minus 90. That is my b value. And then plus, well, the rest of it is just all one big term. So x squared minus 30x plus 450 still equals 0. So all of this other stuff, any non-y terms, those are going to represent c. We're going to use those a, b, c values to do a big bad quadratic formula. Now, I'm going to change back to more of that purplish color because I feel like that blue is, I don't know, it's kind of bright. Okay, we're solving for y. So, y equals negative b. So if we say negative b, that is the negative or opposite of 4x minus 90. So I'm going to say negative 4x plus 90. Plus or minus the square root b squared. So b is 4x minus 90. So I'm going to say 4x minus 90 quantity squared minus 4 times a, which is 4, times c, which is x squared minus 30x plus 450. All over 2a. So 2 times 4. Now, I guess if you want to get really technical, this is solve for y, and you could put it in your calculator. I would encourage you to do a little bit more cleanup here. And the big place you can do some cleanup is under the radical. So I'm going to keep this as negative 4x plus 90 plus or minus. And then under that radical, I would do some multiplying. So first of all, when you do 4x minus 90 squared, remember 4x minus 90 times 4x minus 90, and I'm going to square that, so I'm going to FOIL. 4x times 4x, 16x squared. Then your outside is 4x times negative 90, so negative 360x. The insides are going to end up the same, another negative 360x, so that's going to come together to be negative 720x. And then last, negative 90 times negative 90 is going to be plus 8100. And then it's, what I would look at this as is 4 times 4 is 16, and then I'm distributing a minus 16. So minus 16 times x squared minus 16x squared minus 16 times minus 30x is plus 480x. And then minus 16 times plus 450 minus 7200. All over 2 times 4, which is now 8. Okay, if you look under that radical, there's some definite cleanup that can be done. So I still have y equals negative 4x plus 90 plus or minus. And then under that radical, notice what happens. 16x squared and 16x squared can cancel. And then there's just a couple of like terms that you can put together. Whoops. Negative 720x plus 480x is going to be negative 240x. Positive 8100 minus 7200 is plus 900. All over 8 again. Okay. At this point, you definitely have a graphable equation. So that is a decent stopping point that you could use. Okay. I'm going to write the word graphable. Okay, plug it in your calculator and go. Now, there are, for anyone that wants to try and follow along, there's a tiny bit of simplifying. In that, under that radical, there is a perfect square of 4. So, let me write out negative 4x plus 90 plus or minus, and whoops, I didn't mean to do that. Under the radical, 240 and 900 both divide by 4. So if you divide the factor of 4 out, well, the 4 can go outside. The square root of 4 is 2 times the radical, and then factor a 4 out. So negative 240x divided by 4 is negative 60x plus 900 divided by 4 is 225. Still all over 8. Now, what was the point of doing this, you might ask? And that comes down to there's a common factor. Each term, if you notice, the 4, the 90, the 2 in front of the radical, and the 8. Each of those terms can divide by 2, and that is what you can do to finish simplifying. So I can say y equals, divide everybody by 2, negative 2x plus 45 plus or minus, and now you can just write your radical, negative 60x plus 225 all over 8 divided by 2 is 4. This is another acceptable way to graph it. Okay? A lot of those ways are. They would get you the right graph. Okay? Now, take a moment, get what you need there, and then we're going to look at this on the graph. If you want to practice typing in, I already have mine typed in, so I'm going to show it to you. And we have, wait, I forgot, big thing I need to do is make this graph bigger. Oh, lots bigger. Is that better for you guys? Okay, so if I can hold it still so you can see, I already have mine typed in. I have, again, there's a plus or minus, so I have to do two separate entries. Negative 2x plus 45 plus the square root of negative 60x plus 225 over 4. And I also have the minus. Now, I chose to type that one in. However, you are more than welcome to type the previous one in. It will work just fine. Now, let's look at what happens when I hit graph. Notice when I hit graph, all I have is a red little line up there. And is that any of our shapes? And hopefully you're realizing it's not. And it kind of curves up. So you have options. You could do a zoom out, or what I'm actually going to do, and this is probably because I know a little bit about what it's going to look, I'm going to go into my window, and I'm going to change my window settings. I need my graph to go higher, which means I'm going to change my Y-max to 20. Your Y-min, you could actually go to 0 if you want a better view on your screen. So the changes I made were Y-min is 0, Y-max is 20. Let's graph this again. Now, notice we have a blue and a red, and they come together, and instead of just having part of a line, we have the shape of a parabola. Okay? Again, when you attempt to sketch it, I know this one's tough for me to sketch usually. Do the best you can about noticing some of where the intercepts are. I think this one goes through on the y-axis between 7 and 8 and around 15. I think the vertex is 3 over and is it about 10 up maybe? Something like that. So, okay, I'm going to put this down. I'm going to attempt to shrink this camera. Actually, you know what? I'm done with the camera. Can I close the camera? You know what? There is a way to close the camera. Where do I go? It won't let me close the camera. So we'll just shrink it way back down here into the corner and put it just out of sight there. And I don't have a lot of empty space here, but in this space over here, I'm going to attempt to put a little graph. Let's see if I put my x-axis down here and my y-axis going up straight from there. About the best I'm going to be able to do. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so I know based on what we did, I said what it goes about in between 7 and 8 and around 15. I know there's a vertex over around 3 or 4 right. And I could do some tracing and figure out a little more exact, but it's not a big concern to me. Maybe about 10 up or so. Somewhere in that area. Now, I always struggle getting the right shape here. Not horrible. Looks about like that. Okay, work on these guys. We can definitely touch base on these on Monday when we have some time and I'm back in the classroom. Your homework, in case you didn't get it written down previously or you're not sitting in my classroom when you do this, is page 618. Numbers 2 through 12, evens. And 43 to 52, all. That is what you're looking at for homework, due on Monday. Let me know if you run into serious issues, but definitely bring questions on Monday. Have a good weekend, guys, and I will talk to you later.